Over the course of about a week, just put something together. I've probably spent more time linking together, so it looked a little bit more like a PowerPoint presentation in WebGL. In HTML, but in itself it didn't take a huge amount of effort. So, now the big thing about WebGL, actually anybody here can just get a gauge of who's used it so far? One, right.
I've used 3JS. So I don't know how it counts, but
it doesn't. So the interesting thing, and probably the exciting thing about using a web-based renderer is that you get all the compositing capabilities of cascading style sheets and HTML being able to actually merge all that in together. And so you can actually have things that basically are sort of sitting, this is going to be running in the background. And on top of that then, you've still got cascading style sheets to do the look of what you want, so you can make it fairly consistent over the application or the information that you want to present. And then because it acts on a relatively thin client, you are basically putting your content online and it's accessible to quite a lot of people without having to do a lot of particular setup. And I mean, this is the goal anyway of WebGL. Whether they actually achieve that or not, we'll hopefully see a little bit more about that. But, that's actually 3JS running behind there, but I'll show that off a little bit more as we go through. So, but it's generally, you can interact with it and do whatever you like.
So have you actually got CSS tidying with WebGL, or is there another way of that?
Yep, you can do that. You can use CSS to set properties that you use inside the WebGL side of things that you're doing, or 3JS or things like that. But in these particular cases, it's more just used to do the static overlay of the information that you're presenting. So, some things to talk about to begin with. And it's not set up for the right. I didn't spend a huge amount of time on the scaling, unfortunately. Main thing to mention, WebGL is pretty much equivalent to OpenGLES 2.0. So what that principally means is no fixed function pipeline. So it's purely a programmable pipeline. Now, who's not familiar with the fixed function versus the programmable? Okay. OpenGL in times past used to have the ability to do things like set up various states, so lights, materials, there were separate functions to basically be able to do this. And then when you go to render, there was something called immediate mode rendering, I think it was. Anyway, so if you want to do a sphere and do a list of triangles, you start off and you say begin, and then you give vertex, color, 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 end. And then you keep going on like that. You can't do that in this version. You have to actually create a vertex buffer, so you get a list of vertices and whatever colours, and then you pass it through a vertex shader and a fragment shader, which is a little bit more effort to begin with if you haven't had exposure to that. Probably you've got like what you guys have, but it's also far more efficient doing it that way, and it's the way that you should learn to do things as opposed to the immediate way. No quads, basically just triangle lists and new lines as well, I think. No display lists, so you can't record up effectively a macro of the state changes that you make and the draw calls that you make and then reload that on the fly. Again, that's not a big issue because that stuff you should be using your vertex buffers appropriately and manage your memory appropriately so that it keeps your performance pretty well. No polynomials, so there used to be, or in OpenGL, there's the ability to execute or evaluate equations and be able to produce dynamic surfaces based on polynomials. You can't do that. You have to declare a precision declaration in the shader. And this is principally because WebGL is intended to stretch across mobile devices, and prior mobile devices which would have had floating point units, so you would have had potentially fixed precision that you have to work with. So there's a call here which is cut off where you just specify what the precision is. Other than that, in the shader side of it, it looks the same as OpenGLES 2, so it's all pretty much identical. Now the other catches that you've got to remember is you can't have non-power of 2 textures, so your width and height must be power of 2s. Again, that's something you probably should be doing anyway, so is it a real issue from a performance perspective? No doubles, so OpenGL of course has the ability to support double precision in both its vertex and they've also got double precision floating point buffers for rendering to and things like that, so that's not available, and no 3D texture support. So all of those things from a generic perspective probably aren't a big thing. The main thing is the going into the programmable pipeline, which really shouldn't be that much of a. It should be where you're starting anyway, because most of the newer technologies are going that way.
What's your no bit mapping line you say?
Good point.
It sounds unusual.
What was that one? Must use clamping. Yeah, that is a bit odd. I'll get that back out when I get it back out here. I can't remember now, I'm sorry, Greg, I'll get it back to you. There's something associated with when you're doing the clamps. And,
that's just in regard to the non-power of twos.
that's right.
I'm sure you can do
That's
that, and
right.
I've just realised it's the line
Yes.
below, yeah. It's
Okay.
only non-powers of two,
Okay.
in the powers of two, you can do all that.
Thank you. Which of course probably won't generally do unless you're doing UI textures or something like that.
Yeah, that would make sense.
Yeah. Okay. We'll come back and have a look at this stuff. But, stop me at any time. This whole thing takes probably about half an hour to 40 minutes, and then we'll be stepping through code and having a look. So but feel free to just jump in with any questions that you've got. Okay, just show of hands again, who's done any HTML, JavaScript? Who else? Okay. All right, so you've got a bit of a mix there. In order to drive the WebGL, obviously you need a HTML page, and in order to actually access the code for WebGL, it's all based in JavaScript. Well, love it or hate it, it's a fairly useful language for sort of doing what you need. What have we got? So I just mentioned on start, you've got full access to cascading style sheets. You can structure your HTML however you like. Essentially, it either uses HTML5 or SVGs. Maybe I'm jumping ahead. Oh yes, no, it's there. You can easily use, because in HTML5 there's a device context called Canvas, and that's what you can do a lot of rendering capabilities on. Or prior to HTML5, there's scalable vector graphics, areas that you could render to, and WebGL will support either of those. One or the other. The good thing about scalable vector graphics is you can then actually save that out, and so then you can then use an image editor or a vector drawing sort of editor to be able to manipulate certain elements if you find that that's going to be useful. Also can be useful from a printing perspective, but generally speaking, you probably use Canvas. It doesn't really matter on the browsers that I've used at this stage. I think some of them in the earlier stages may have had some performance issues with using Canvas or SVG or vice versa, but they're both pretty much widely accessible now. As you know, with JavaScript, it's meant to be cross-platform. Reality is there's a few little caveats here and there between the browsers that you've just got to watch here and there. My favourite one that I often get caught with is even just parsing a simple data string is different between Mozilla, Chrome and Safari. Oddly between Safari and Chrome because they use a similar sort of JavaScript engine, but I've been caught up before. Although that might be the mobile version of Chrome, I think I have one. We'll go through the different steps of the, actually we'll bring that up in a second. Essentially there's just three main steps that you have to think about. You guys are pretty much familiar with doing interactive applications. So creating new content and your shaders to begin with, setting up your render loop. The important one that you probably need to be more familiar with WebGL is effectively what happens when you do your update, your resizes and using the contexts. And probably a good opportunity to bring it up. And this is probably something I should have prepared earlier while we were chatting. I've been this like having too much of a gas bag. So just see if I can get to that quick. She's there. Oops.
So regarding WebGL, it's written in C++, right?
I would presume so, but in terms of when you access it, you're using JavaScript.
Right. So you write it in C++, compile and embed that object into the browser.
Now, you're talking about the shaders, or are you talking about...
I'm just looking.
Okay. If you're using the programmable pipeline,
Yeah.
all of your setup code to set up your shaders and that sort of stuff is all done in JavaScript. The shaders themselves are based on the C-like language.
Oh yeah, of course.
So that's possibly what you're thinking.
Yeah.
Then you're really relying on whatever the browser's actually done. Presuming they've done in C, C++, and probably a bit of assembly here and there.
Okay.
Unless you've seen stuff and you're thinking of it in scripted that people might have heard of, which compiles C++ to JavaScript and will convert your WebGL installs to WebGL. So there's a lot of demos on the net these days that have actually been written in C and have been converted to JavaScript.
Yeah, possibly.
Let's see if there's something here. Alright. And has a colour scheme. Okay. So, actually, this is going to be annoying because it's going to have to jump back and forward. I should size it a different way. Hang on. Just take it out of this mode. No, come on. Thanks for the screen. Work. One thing about OS X that irks me is they don't have each corner being equally sizable. Come on.
And hitting maximize doesn't maximize properly.
No, not for this one. If I did that, alright, it actually went to the other screen previously. Rightio, I'll just show you the HTML to begin with. So that first screen, that's all HTML. I've tended to put my JavaScripts in subfolders, like subfiles. So you'd be familiar with the usual sort of stuff. You just declare it as a HTML document, and I think what have I got here? It's just the style sheets. This first page, my apologies. I did end up having to use what's called an iframe. Because I'm mixing a bunch of different WebGL applications and Java3JS applications together, one thing that really irks me about JavaScript is its scoping is more or less non-existent, and so there are a lot of clashes going on. So an iframe is just a way to insert another web page inside the HTML page without it, with it being more or less sandboxed and contained.
Does that mean you can change what page you're looking at within that page, or is that?
You could, potentially, and insert it in different browser session there, yes. But for my purposes, it's just fixed pages only uploaded into there. So the more interesting one would be this one. Okay, so this is the Earth and Mars. Actually, sorry, I'll go a little bit further than that. This one. Alright, this is the pyramid and the cube of spin, and it's based on a Venhi example. And if you haven't seen these examples in OpenGL, thoroughly recommend it. They're just a really nice, simple progression of adding different features and functionality. This particular one, I think, was their fifth example, and I've included all the JavaScript in this as well. So we've got a really long arm.
Even less boring.
Yeah, actually.
Oh, you guys prepared over there?
Probably just look at the mouse cursor on it.
Yeah, I could do that too. There we go. Alright, to begin with, there is a bit of boilerplate stuff that's required. Now, the thing to mention is WebGL is still more or less experimental. And this is one of the disadvantages of using WebGL, is it's supported pretty well in Chrome, Firefox, and Safari. But there are variable levels of support, and you get clued in a little bit by the Chrome context that you get when you search for it is WebGL-experimental. So it's still being ratified by the Web Consortium, so that will be a while off before that comes through. But that said, it's still pretty well supported across those three browsers. If you want to get to Internet Explorer, we'll talk about that one a little bit later. But this first stuff up here is actually some boilerplate that's needed to deal with the differences between the three browsers and getting the context where you can get on the render on. So I'm not going to go into a huge amount, except that down here you get a bit of a feel for, even just looking for the context. The ones that you're meant to, by the standard, is more or less just be able to search for WebGL or 3D, but then Chrome uses experimental WebGL, Safari uses WebKit 3D, and Mozilla uses Moz WebGL. So already they've broken the ability to do cross-platform. It's just this sort of stuff and you get it. What it really does is it replaces there's a function which is up here, this get context. And that's the nice thing about JavaScript is you can more or less overwrite anybody's code, which is a good thing and a bad thing. But that'll give you that ability, which you can do that. The other thing it does, I think, is deal with when you lose your context, being able to re-establish it. So this is just a set of boilerplate code that's required. Now, I do have a link to that somewhere. And I can. Do you guys post these up?
Mm.
Alright, I'll give you this after this anyway. After all that interesting stuff, the next things we've got is I'm using a matrix library, an external one called GeoMatrix. It's a reasonable one. I wouldn't say fabulous, but I wouldn't say writing your own is that exciting to do anyway. And there's also, this one's not needed at the moment, this is some performance tracking tools that you can use. And we won't have time to go into that today, and I may not have it run, but you can actually do more or less like your developer tools in Chrome. You can bring up a window that shows you where your time's getting spent in your render, so it can be quite helpful. Next thing down, this is fragment shader, so shader fragment shader. Now if you, again, familiar with HTML, so this is just a script tag, but its particular type is this X shader, X fragment. Down here's a vertex shader, X shader, X fragment. This one's really simple, and it does look like, if you're doing shaders, it looks like a pretty normal fragment shader. So it just specifies a colour to output, and it just basically, colour that's being input, which is your vertex colour. So it would be the interpolated vertex colour at that particular pixel point, and it's just assigning it to the main fragment colour. Okay, so nothing special, so it's basically just taking the vertex shaders, colours and pushing them through. And this is the thing that we saw before, you have to specify what precision you actually want this to run. And that's specific to WebGL.
So doesn't it default to anything if you leave that out? Or?
No.
No.
And it'll just fail to compile. And the way that you detect that is you run it and it actually you see it at runtime.
Is that like a design choice or something?
I think so, and I think it's so that you can supply several different precisions to different behaviours, but I couldn't give you a particular. It's more or less probably an assist to help the device renderer deal with what you're actually getting. But I'm sure there's a fairly long and interesting reason they may have to do that. And maybe it's something that will disappear after a while, because you look at most of the mobile devices these days, and the GPUs that are really quite sophisticated. So this was more designed for the Nokia. It's just a smartphone, more like dumb phones that you can run stuff on. So the vertex shader, again, is pretty simple. It's passing in a model view matrix, a projection matrix, and then it's just using those to take the vertex position and generate the vertex, the screen space vertex position. And then the vertex color that's coming in is just getting assigned straight to the vertex color, the varying vertex color, which is used in the fragment shader up here, which is varied or interpolated across the pixels from one vertex to another.
So geo position is something that's automatically defined?
Yeah, if you're familiar with GLSL, or if not,
Well, not the shader language.
no worries. That's part of GLSL, and essentially it's the next stage. It's one of the outputs that you have to fill out. So geo position, geo normal, geo text chord, there's a range of those different ones. And then these other values that you can put in they're a bit specialised. If you declare a varying, so up here, I know you actually, sorry, yeah, that's pretty fine. These ones, if you declare a varying, then over the course of your primitive I'm trying to think of, it will vary the value interpolated based on the triangle, based on the three triangles you've got. Okay, so I'll jump down to the bottom to begin with, just show the HTML. So all the HTML really is, that script and all that stuff, by the way, was in the head. But then right down the bottom, you can see it. All it really is onload, call this WebGL start function, and then it just provides a canvas element, which we've just got a certain ID for, and then just some styles if you want to override the styles. And, I could have been a little bit more clever about that and made a little bit more scaling based on the size of the page and stuff. But once I started getting the iframes, then I got a bit limited in what I could do. Alright, so back up to the shader code. Now, because we're dealing with WebGL, there's still quite a lot of boilerplate stuff that we have to do. When we get to 3JS, or there's other engines that you can get, you'll find that this collapses a bit. So don't get too put off by it. Rightio, then I just have to find my start. WebGL, that's not the start, is it not? WebGL start, there it is. So it's going to Okay. So the first thing it does is it gets the canvas, which we've named down the bottom here. That's the full canvas. Calls a initGL function, init shaders, init buffers. So this is just our setup. Then we clear the back buffer, enable the depth test, and then we start into our update function. Now, just to note, once you've got and it's stored in here, once you initialize your context, we're storing that in a global variable called GL in this case. Then most of your OpenGL calls will pretty much be visible from that GL. Okay? And there's some reasonably good documentation out there, and you'll find that if you use OpenGL ES2, you'll find that most of the functions are just accessible from just doing GL.this. OpenGL, as you may or may not be aware, is a functional-based language, so there's no object orientation in it, but this more or less fakes it, if you like. Things to be aware of, in particular, if you guys have been using JavaScript a bit, is I mentioned about scoping. Scoping is a bit woeful, but also the this pointers and the object orientation. Be very, very careful. This is one of my real pet hates about it, and I won't go into it too much, but effectively this pointer isn't the object that you're calling necessarily. It's the object that is calling that method. Okay? So if you have in the stupid example, if you create a sphere and you want to set a colour of the sphere, and you call sphere.setColor, when you go to that function, this pointer isn't the sphere, it's whatever's calling it. Okay? Very, very, it just kind of flips you around a bit. I don't know exactly what the reason it is. Just be aware, particularly if you're doing an initialization of an object. And there's some interesting workarounds, if you like, called closures, which I can get into after this if you're interested. It's just something just to keep a heads up about, be aware of the terms, and kind of go from there. It wasn't been knowing the brief to begin with, but now I've got my head around it, and mostly it kind of makes sense. So up to the initGL. So we're here, init shaders, initGL. Rightio. So this is calling canvas.getContext. Yeah, we've replaced this method further up with the boilerplate stuff that just does the check between the different browsers. Essentially what that does is just gives you this object, which we've declared as an overall variable. And whenever you declare a var outside of an object, of course it goes into global space in JavaScript. A bit messy, I know, in this context, but from GL it makes sense, because you create more or less like a manager object for it, if you like, or a singleton. We just want to set a few initial properties on that, viewport width and viewport height. They aren't part of WebGL, that's just my local ones that I store. And whenever you resize the window, it uses those to scale it up and down.
Can I ask you a quick question?
Okay.
So since you're using Chrome, is that why you're setting the experimental WebGL? Would this fail in?
It doesn't matter in this case, because it goes into that overridden method that we gave it, and it will actually look for any of those.
Okay.
And it'll pick that up and then find the appropriate one to mention. So you can just rely on WebGL. For me, that was just because I started off in there before the boilerplate, before I found the boilerplate code, and yeah, that I should probably change.
Do you know what the idea behind the context is? I mean, can you get other contexts, other APIs out of Canvas? Or?
Yes, you can.
Yeah, good question. I haven't done it myself. Did is that things like printing and things like that as well?
The
There's
gist-
a 20 one
the
as well.
default, like, the gist is a canvas is basically, is anyone, you know what a P buffer is? It's like rendered a texture. So basically a canvas is, you tell them how big it is, and then you can get different drawing contexts on it. So for instance, the default one that's been there for donkeys now is just a 2D one, a bit like the old turtle graphics type stuff, where it's like, you know, line 2 here, you know, you specify a couple of verts, and it's just plain 2D rendering. And then sort of there's a couple, and I think SVG rendering might be another one you can get on it. I wouldn't be surprised. There's I think what was it, OpenVG, big like that is.
Okay.
It's like I wouldn't be surprised if at some stage they make a WebVG and add that. The idea being here's a rendered a texture, and then you can get a different rendering environment on it, basically.
And it's used quite extensively, because if you do anything to do with the graphing packages or visualization, sort of 2D packages, there's one called D3, which is really very popular.
I wanted to ask you a question about that actually.
That uses the context for getting the vector graphics. And there's nothing stopping you from mixing that stuff in more or less on top of, or using the opacity to run on top of or behind or whatever. So you get a lot of powerful capability in your visualization. Unless you're using engines though, you're still doing quite a lot of the base stuff yourself. So, and there are people who are built on that, engines like D3. Okay. Rightio, so we're initializing GL, initialize shaders was another one. That's what this looks like here. If you're familiar with doing shaders inside WebGL, basically what you need to do is grab the text, which is sometimes from a file, sometimes from inside your code, attach it to, sorry, I'll back up a second. You need to create a program, a shader program, which usually encompasses a vertex shader and a fragment shader. There's various extensions in later versions of OpenGL as well, things like geometry shaders and whatever else, but that's all you've got access to here. Then you pull in the source for the shaders, and in this case it's going to pull it straight from HTML, and then you link it, and then you set up various parameters that you're going to pass into it. And that'll include things like buffers or your matrices that you want to pass in, or constants and things like that. And then that's used, you activate that effectively you bind that onto a buffer, and then you use that in a draw call, and then you use the shaders. Okay. So what we've got up here, first thing it's doing is it's getting the text script using these get shader methods. Now these really just they're searching through the HTML document. In this case, it uses just straight HTML to access the document model. But I'd recommend there are other tools and utilities you get. jQuery is a very, very popular one, and makes it searching for all these elements really much easier. And then it really just hunts through, finds the appropriate, in this case, X shader, fragment shader, and vertex shader. Oh, actually, there's a little bit more than that, sorry. It pulls in the shader source and compiles it, and it looks like, and then I just check to see whether it compiled appropriately, and then just output something if it failed to compile. Okay. So I forgot that it actually pulls that in. So at the end of this, we'll end up having a shader object, which could either be a fragment shader or a vertex shader in this case. So we've got our two here, which is our trouble about using a mouse pointer. Fragment shader and vertex shader. We create our program that's going to bind them together. We attach the fragment and vertex shader to it, and link them together, and then we just check to make sure that that linked appropriately. Okay. Next thing is we activate that shader program. Now, because it's a very simple application, we only have the one shader. I do it in the setup. Obviously, this would be something if you've got multiple different objects and you're rendering different shaders or materials effectively, you'd have to basically enable that shader before you go and do the next rendering of the specific thing you want to do. And again, also only setting up the fixed vertex buffers here and the parameters associated with it too. So what we're doing here is we're getting a pointer to where the array of vertex positions is, so the vertex array, and a colour array here, and we're storing that in our shader program. and then we are getting, in this case, just getting access to the projection, the model view matrix and the projection matrix. They'll get filled out a little bit later. Or actually, this is a little bit of leading into that. There's some simple pushes and pops I use just for being able to manipulate an existing matrix and then sort of pop back up the hierarchy. I'll get back to that. Initializing buffers, again, this is all very base level stuff because you have to, I'm not doing any model loading and so on at this stage. You generally wouldn't get down to this level unless you're doing dynamic geometry. So we set up a list of vertices for our, what are we doing first? Probably the cube. And I'll leave this to sort of a later stage if you guys want to have a look through your own and come back with ask questions. Essentially just setting up the vertex buffers, the characteristics of them, and how many floating point numbers they've got in them, their stride, all that sort of stuff, and the colours associated with those. And you're binding it to a certain buffer, okay? And also setting some, so we've got a pyramid vertex colour buffer and a pyramid vertex position buffer, and the same for the cube, so all that's doing that. Coming back to that one, alright. Actually that's probably it to talk for that one. So that was the init shaders, the init buffers, and then we go to our tick. Now our tick is, and this is the difference that you'll have with standard WebGL application. You will either use the, that's not the flush, what it was do to set up to flip it, I can't remember. There'll be a call on your redraw, sorting buffers, something like that. But you'll have a timing mechanism set up to do on your refresh, your vertical refresh, so that you can run it at a refresh rate, or you might do it.
Your VSync.
Your VSync, thank you. Brain's going to be a little bit funny today. In WebGL, you don't get direct access to doing VSync. Effectively, you need to. There is a function that WebGL provides to tell you when it's appropriate to redraw. Now that could be that the VSyncs happen, or it could be that someone has clicked on your page and refreshed and brought it back to the front scope. So there's this thing called request anim frame, and basically you give it a method that it'll call back on the next time it needs to redraw. And you have to do that every time you do a draw. Okay?
So is that an API function?
Yes.
And is it the same for every browser?
Yes. So that's the only odd thing that you'll find more or less between standard WebGL, OpenGL and WebGL. So effectively we're just calling ourselves to say, next time you're ready to do the render, call us again. Okay? And then we do our draw scene and just a simple animation. So the draw scene is, again, some relatively standard OpenGL calls. In this case, setting up our viewport, clearing it. These are getting to the specific matrix methods, which that matrix library is provided. So we've set it up to perspective. So in OpenGL, it has utility functions to set up perspective matrices, but OpenGLS doesn't. They're very sort of basic in that regard. So we're just setting up basically position where the two objects are based on their current animation position, also rotating it to an appropriate level. Down to here, a particular call, we're binding the vertex position buffer into this array buffer that we've set up in our shaders, okay? Which is, which is here. And we're doing the same for the colour, so here's the colour buffer. Then we're setting the matrix uniforms. I think it's just a method that calls, set matrix uniforms. Alright, these are OpenGL calls again that just set up, in this case we've set up a shader uniform, which is going to be the model view matrix and the projection matrix. And I promise the other ones will move on a bit quicker than this, by the way. Back to our draw, and then we finally get there. We actually, where are we? In this case, it's the cube. The pyramid's further up, but we finally get to the draw elements where it's actually going to draw the triangles. Here's the number of items we're drawing, and just what the index is, what type they are, and that's it. And it pops the matrices so that it just matches up to keep those so that we can manipulate with the animation. The animation just generally just sets up rotation values based on current time. Okay. That's it for WebGL. And we'll pop back. Any questions on that one? Sorry that took a little while to get through that. There was a lot of bouncing around in text. At least it was coloured text. Okay, get that to something a little bit more interesting. Right. So, what are some tools and bits and pieces? Hey, there we go. Thought I had something on there. It's going to cut it off again. Main thing is you need a text editor that's actually going to be reasonable. You want your code colouring, all that sort of stuff going on. If you can bring in the help in some fashion, so we can do auto lookups and so on, that can be useful. I think mine doesn't at the moment, which would be nice. But I think I've used what's mine called? Sublime. Find that excellent and very cross-platform. Anyway, Chrome and Mozilla have got really quite good developer tools, so they can actually do the debugging side of it. You get to that in Chrome by View, Developer, and Development Tools. And hopefully this won't completely screw me up. Anyway, in here you've got access to all the scripts that you've got loaded, and in that you can then set breakpoints just by right click. No, it's in there somewhere. That's a breakpoint. Right click. That can stop you. You've got watch expressions, you've got call stack. You can also have a look at elements in your HTML. Won't mean a lot at the moment, but effectively it'll sort of show you as you move around. Where else are we? You can do some interesting things like you can look at the timeline as you've done the rendering of your page. This won't include the WebGL elements, but if you've got a heavy HTML page, it can actually show you what's taking time and stuff like that. So there's some quite useful features.
A general web development question. Yeah. Can you put this up on the web? Can anyone just go in and see your JavaScript code?
Yes. Yes. So completely. Hopefully that's going to kick back in. No, all right. I did stop it. Good. Grind. Anyway, yes. Now there's a couple of things you can do about that.
Parse it till it's unreadable.
Pretty much.
Obfuscate
There's
the
lots of
JS.
tools for that.
That's it, yeah. Obfuscation, and generally speaking, you actually want to run them anyway, because what they do is minify your JavaScript, because it's text, and you've got really big programs, then it's going to take time to download and then compile. So that basically how a minifier generally goes, takes all the white space out, and minimises all the variable names, and even doing that can make it a bit hard. And then there are other obfuscators that can reorganise your code and do all manner of things to try and make it harder for people to reverse engineer. There are other ways to do this as well, where if you're talking about client-server style things, there are good technologies like Google's Web Toolkit, which you write as a Java backend, and it generates the JavaScript for you, which can be really useful because those differences between the different browsers, you can actually generate the JavaScript that needs to be run on those browsers instead. And as a result, it also has the notification obfuscation into it. And because it's a subset of Java, if you like, and it's trying to translate the Java into JavaScript, it also makes it quite confusing when you're trying to parse through the code. So, yeah, if you put most of your logic on the front end, which is really what it's designed to do, there is limited protection. As to future sites and support, there's always been talk of binary XML in some cases and things like that. I don't think they've really got that far.
I'm surprised there's never been like a compiled version of JavaScript just for the performance of downloading it.
Yep. Yeah, I guess you're just talking about such a broad range of platforms.
True.
You know, I guess.
But not even compiled to native code. Compiled to some sort of bytecode even.
Well, I think that's what Java.
It's kind of moving
That's
that way.
Java for me. So
Anyway.
yeah.
There's a thing that's really new called ASM.js, where I mentioned before, I don't know if anyone's heard of encrypting. So basically you can take your C and C++ code, compile it to JavaScript, and it basically comes out as minified JavaScript. And because JavaScript doesn't have any concept of floats and ints, for instance, to try and make it fast, they use lots of sort of tricks, like oring a number forces it to be an integer because you can't or with a float. So they've got all this stuff. And basically the guys who make like Mozilla and stuff have looked at this and gone, hey wow, we can make that run even faster if we make the the JavaScript engine aware of what that kind of code is. So it's getting a bit ridiculous because it's kind of like just compiling your C code, but they've actually now come up with this thing where you just put a string at the front of your JavaScript file that says ASM, and it basically cuts out all of the crap of JavaScript, and so it basically becomes like JavaScript assembly. It's basically JavaScript assembly. It may as well be a compiled bytecode, and it's kind of their response to NACL, native client, that Google have done, which is, I think, if anyone knows what LLVM is, which is basically they're using LLVM to basically be just-in-time compilation for the web to do the same kind of thing. So it's really weird because they've gone from this high-level language and they're creating this version of the high-level language that's really, really low level.
Yeah.
It's like,
Alright, so decent text editor, Chrome and Mozilla certainly. Safari have got some developer tools, but I don't think they're really Chrome and Mozilla. If you're using and are forced to use Internet Explorer does not support canvases and HTML5 too. In the later ones, I didn't know what they'd done with IE10. I actually looked at the versions of it. But certainly 6, 7, 8 got some basic support in 9, but it's really patchy. If you're forced to use that, they certainly have no WebGL. There is a plugin to Internet Explorer called WebGL, which actually gives you the ability to just standard WebGL programming in as well. It gives you a canvas that you can move to and the same capability. There is also a plugin which I haven't looked at a huge amount yet. I want to use it for other reasons. There's a Chrome have a Chrome frame, which is effectively the Chrome renderer running inside IE. And I'm presuming that should also allow you to get access to WebGL in there as well. They did that principally because Google's apps, their Gmail or whatever, they were finding it breaking so much on IE that they decided, screw it, we'll create our own plugin that's just our own stuff. And that's what you're actually forced to use if you use IE these days. There is I mentioned some tools out there that give you profile information associated with your drawing and rendering. What's called Web Inspector. There's also some error checking stuff that can go over your code, I think, and check for basic OpenGL errors. On top of that, though, you've got engines. The creators of Irrelict have created something called Alex Engine, and it's not related to Irrelict at all, but it is, I think it follows very similar patterns. That's Copperlict. Alex Engine is another different one. I won't take you to see those at the moment. I'm going to show you a couple of things with 3JS. 3JS seems to be one of the most developed and stable versions of engines that run on WebGL. And there's two catches I wanted to talk to you about, which is if you're using the browser for development, just be aware that if you're loading stuff from a file as opposed to your own Apache server or whatever else, Chrome and Mozilla and and Safari are all limited in what they'll allow you to load straight from the file. So if you browse to a file and open it in the browser, they won't allow your JavaScript code to load files and do whatever else. There's a security limitation.
Chrome actually has a command line idea that you can disable all that.
And Safari have got something that you can enable in their properties as well. So just be aware that you'll have to hunt for those. They're fairly easy to find, or you just do a search and find them as well. The other one is browser caching in JavaScript rather. Chrome, I'll get there in the end. Under the View menu, Developer, if you go Developer Tools, down here on the bottom right hand corner, there's a little cog, go to the settings, disable cache, is there, okay? So you need to go hunting for that one. If you don't do that, you will just confuse the absolute crap out of yourself.
Why has it changed?
It isn't working.
I think probably anyone who's done that, anyone who's done JavaScripting on the Chrome has had to pull their hair out and find that little option.
Very much so. So, I've shown you some basic examples. We'll come back and have a look at the front example and this example as well. But there's still, some pretty impressive stuff you can do with it.
Is this something you made or just something from the web?
I just whipped it up this morning. No, I can't lay claim with this one.
Pretty good.
It is pretty cool about the scale of stuff that you can get to. And that's really the key takeaway with a lot of this stuff is, in spite of there being limitations and it's almost not quite there yet, people are doing a lot of stuff with it. And it's that interactive experience on taking some data sets or some media and so on the web that's very accessible and easily accessible by people. I can look at stuff on here, on mobile platforms, that sort of stuff, without having to write a specific application for them. And you just open and broaden your audience without having to actually get access to the stuff. And I'll show you a couple of other really cool, actually, before we get to that, I will show you some of the code here. So if you have a look at that front page, which is this one, right, this is the 3JS equivalent. It does more, but it's similar to that Nihi example. Now, again, we've got the boilerplate at the start, so just try and ignore that. But if we get to the script, jump down to the HTML again to show you. There is no HTML extra bits on this, because this script actually generates an element to add to HTML. It's only a real difference. So let's find out 3JS. Alright, so one big difference here is it pulls in the 3JS unified script. Okay, and then as a result of that, and then it just goes on to execute this next script. Rather than use a callback, it just starts it up in the header. So we set up a few things to begin with. Add a listener for a mouse move, because we saw as we were moving around that sort of box thing that was going out, sort of moved around. There's an init call, an animate call, and I think that was pretty much it. In terms of the calls, I'll just jump down. Right. So the init call, in this case, as I mentioned, it's creating a div element. Just a div is like a division area. It's just a basic 2D area you can add to any HTML page. Using it as a container, that's where it actually adds it to the document. And then this is, okay, there's this 3 object, which is 3JS. And here's setting up a perspective camera. Here's creating a scene, because there's a scene graph in 3JS. Here's creating a cube geometry material. So they've got models, so they've got being able to do loading of various models. And so you saw with that car, that was loaded from a file. And it's got a range of different support for OBJs, 3DS, Collada, probably, I don't know if it does DXF. Can't remember. Anyway, there's about 5 or 6 different formats that it supports. Similar again for textures. So in this case, we're just creating a mesh object with this geometry and material that we've created. And then we're adding to our scene, we're adding that root mesh object. And then it gets a little complicated because what this is trying to give a demonstration of is the scene graph hierarchy. So effectively it just creates a bunch of cubes off in 6 different directions, and then it animates those cubes using sine waves. I won't go into that too much. But effectively this is just doing a loop and creating a new mesh along the same box geometry that we had and adding it to its parent. And then again, and again, and again, and again, and again. So 6 times, because it adds it onto each 6 separate face of the cube. Then the real important stuff is just here. So you get access to the 3JS renderer just by this call. We're setting the size of the window, setting the clear colour, telling it we, in that case, don't want to sort the objects because there's no transparency. Thank you. Container renderer DOM element. Why does it need to do that? Oh, sorry. This is the container that we added with the div up above. So what we're doing is we're getting the renderer's document element and we're adding that to our container. So that just becomes a HTML element then. And then we're adding a listener so that when we resize, we call out on window resize. And all that does is just calculate. It's got a camera object from 3JS, so it just recalculates its aspect ratio and updates the projection matrix and sets the overall size. That's the mouse move. Just sets up this event. Sets up this mouse X and mouse Y, which we use in the renderer further down. The animate, again, this is similar. It's got the request animation frame, and we're calling our animate function, so we still have to do that. And I just have the ability to show it up, and it just calls our render. Now the render, a lot simpler. We don't have to muck around with all the OpenGL, set up the buffers and that sort of stuff, of course, because it's a scene management hierarchy. So what we do, we set our current camera position using the lookout methods and utilities in 3JS. Then it just calls the traversal with, what's the object? That's basically, this is JavaScript for you again. Nice thing about JavaScript is you can do lambda functions, they're called. So it's effectively passing into this root traversal method a function which I'm declaring here. Okay? All that's doing is taking this X rotation, Y rotation, Z rotation, and setting this overall based on the sine wave. Okay? That gets called effectively on each object in the root hierarchy, which is all the cubes that were attached. And the last call is just to render it. So it's a lot simpler. You don't have to worry about the shaders and that sort of stuff, because you get similar fixed function pipeline capabilities of material, lights, cameras, and models.
Can you plug shaders in if you need to?
Yep, most definitely. So we've got pretty good control, and as a matter of fact, I haven't got a link to it yet, but they've created, using HTML5, they've created a shader editor, which is what you'd expect in Unreal. It's material editor, so you've got your outputs and things, plugging in inputs, and sort of functional blocks and so on, and it generates a shader in. So there's a lot of stuff that they're actually sort of heading on with. I haven't seen any scene graph management tools at this stage, so world builders and things like that. I don't doubt that they'll come for it.
There's a simple little editor thing that comes with 3JS. Have you seen that?
I haven't played with it.
It's very simple, but it looks similar to like 3ds Max or something like that. You can put down a few primitives and position them, so it's a very simple starting point for a world builder maybe.
And all the code will be there, so if you feel like actually basing a game builder on it or something like that, it's something you could do. Oh yeah, so there's that. Any questions about the 3JS thing? Right.
That show GL, is that a variable that you've added?
Oh yes, yeah. I've just got that for trying to disable the different pages from rendering your background. Actually, no, I don't want to do that yet. It's just one of my variables that I was using when I was debugging. And it's just in the window class, which is your overall, effectively global in JavaScript. Right, yeah, back to here. On the last page. And I was mentioning about people taking data sets and using this to basically generate information, give people experiences by just using the web browser. And this was a pretty awesome one actually. So 100,000 stars using point rendering in this case. And you've got the ability to go at different scales. Oh, that's beautiful. Very pretty. And, whoops. Hope you all felt that. Alright, and you can go down to the scale of your local cloud. That's the, what's this? This is, they've got a scale somewhere around. No, they don't? Okay, sorry, zoom back in. These are closest stars around us, things like that. So you can mouse over, it'll show you what they are, you can click on them, it'll take you to the star and do some statistics about it, show you roughly what the star colour is, things like that. Out again.
Is that just a extra background?
Yes, yeah, they've got a cube back in the background as well, showing it. But then you can zoom back in. There's one light year, that's the Oort cloud from the solar system. Zooming right in, get the mouse out of the way. There's our solar system, going down to, and of course I think they've got, oh no, they don't have those bouncing.
So right into this room.
And then there's a tool that they've got where they can just take you through and show you the different stages.
How did you actually find our solar system?
So thankfully there's a button that cancels the reset.
Oh, okay.
So, I use those opportunities like this. Say, look, I just know these things. Really good at this. No, I'm not. Anyway, so, just to give you an example of the sort of experience that people can have, and, they can stop this at any time, examine things around, keep going, whatever. There's some other really nice ones. In terms of visualization perspective, which is sort of where my key interests are. Let's take this one. This shows the movement of arms and ammunition from that data set, 1992 to 2010. hopefully the web is really big. It's not too big a set, but
Did you connect to the Wi-Fi here, or are you
Yeah.
using?
that's certainly something to note, is a lot of this stuff, of course, you need a connection, and that's one of the downsides, but of course it'll be positive.
Loading individual bullets down.
Right. We'll let that one load, and we'll come back.
Play with the star maps.
I want to do some 3D visualization, and I've been playing around with D3 recently
Yep.
for turning stuff.
Yep.
Do you know if it's possible to do 3D visualization?
Not in D3.
Is there any way to hack it?
Other than fake stuff.
Like
actually,
I'd
sorry.
like to use it with 3JS
I wouldn't say
to actually
never.
generate a scene graph.
I wouldn't say never. And for those that don't know, that's D3 D3. D3 is a really nice JavaScript library for being able to take set of data and then being able to generate a rendering of it. And I've killed our performance. Let's get there. This is another one. Let's see how that seems to be loading. So we'll come back in. No. Alright. So this is a really small view of what you've got. There's lots of examples. So go down. This one hopefully, no, still get there. This is going to be weird.
So D3 needs some kind of DOM to work with, right? I was wondering if you could make some sort of an adapter like on the scene graph so that was the DOM it was working with.
Maybe.
Sound like a lot of work, or?
I don't know. I think if you spend a lot of time in D3 code, halfway through, and what I'd suggest is post to the forum, see what he's done. I certainly haven't looked in those directions. I don't imagine it's beyond capability, but how far you have to get into D3 itself. Maybe it's because they use this chaining mechanism to basically generate extra data. Given in JavaScript, you can effectively override any method anyway. There might be an ability just to override what they've got and provide that data from the 3D data source instead. Hey, here we go. Alright, so nice and pretty, flashy, and actually does something interesting or useful, because it'll show you over a period of time who are the main perpetrators of the arms trade. And you can probably see the balls are going in the direction of where that stuff's getting sold, and of course it then gets users additive rendering, of course, to emphasise their laws. And you can see there's a lot of stuff coming out of North America. A bit of stuff coming back out of Japan there, I think.
What's the difference between the yellow and the blue?
I think it's just to help differentiate some of the directions.
Going out, going right.
Actually, no, sorry, it's over here. Blue, civilian weapons.
It's really about Japan.
No, it is. It's just a differentiate.
Guns down
Yeah. So, a lot of stuff actually coming out of Europe there, I think. And going over to North America as well. A lot of stuff going in the Middle East, which is really quite unfortunate. And even stuff coming from the US into Australia, New Zealand, Philippines, whatever. So, and you can change over time and so on. Okay, here's an example of, here we go. Let's go back in. This is back to D3, sorry. And this is a really nice one that I like. I think it's this one. No, it's not that one. Go back. The interactive nature. Reading diagrams. Here it is.
Just guessing, that's the canvas, not WebGL, I'm guessing?
SVG.
Correct.
Oh, it's SVG.
Actually,
or canvas.
The thing is, you can do what you want with it. It doesn't define how you render it. I think it's the only requirement is it has to have a DOM, like HTML DOM or SVG DOM. That's why I'm thinking if you could make some sort of wrapper to make a DOM over the scene.
So what's the gist of what it does? You give it a bunch of data in XML or something, do you? And then
You-
visualize it.
You have data.
It can be wherever. It can be CSV files, it can be XML, it can be other formats that you specify.
So it's just got adapters kind of thing and understand the tree structure as well.
And then using the way that that scoping and the fluxy way they do object handling in JavaScript. They have this chaining mechanism that effectively you're passing the data through in some cases down to successive levels where you're doing stuff with it. And sometimes there's a return going back, which is also affecting the renderers or whatever else you do.
That actually is quite a good way of describing it, like thinking of it as like a pipeline,
Yes.
and you write the code for the pipeline, your data passes through that and turns into a visualization.
But the tricky thing is some of it also comes backward as well. That's quite the background there. It's again not the right one. There's a chord diagram like this, and you could affect how there were like a bazillion connections between things over here and here, and you could affect the weighting of how they clump together. So things that have got common connections would clump them together based on just a dynamic setting that you were having. And it very quickly showed you where there were really quite where there are associations. And I just can't find it for the life of me. But they've got really like a nice heap of examples. What they don't have is a simple example of drawing and updating, animating line chart with range scale, which is what we're something that throw your mind off.
So all the different graph types and visualizations, like are they part of the library?
Sorry.
Is it all the different graph types, are they part of the
Video
library?
credit card details.
You still have to do a lot of work yourself. Like it's not for creating simple charts. Like if you want to make simple charts, go and install a Google chart or something. But D3 is very powerful, it's basically you have to write the code that creates the visualization, whatever kind of graph or whatever it is you want to make.
Rightio. Here's another 3JS example. So there's a ball up at the top, and it's a ball table. Basically, but it's using Google Maps. And as you do that, hang on,
You get a drawer.
Oh, it's stuck.
That's the ridge.
That's the ridge. Here we go. As you go along, there's sort of points of interest. And there we go.
That's a
boat. And then we're on to the next one. So, that's mixing in a web data set that you've got, wrapping it around a really quite interesting visualization and adding a game all the time. So, that's cool.
That's awesome.
Presentation, and it's basically someone who's produced a story and put music to it, and then provided the user with the ability to change the way that they view. There's two different views that they can swap between, more or less, and they can sort of slide between them. And it's more or less the representation objects they have in it mean different things depending on which world you're in. And so, it's just a good example of how people are taking this media and moving conventional storytelling elements and that sort of stuff into it, and being able to utilise these tools. So there's really some good examples out there of the sort of things that you can use this technology for. I'll let that go in the background, maybe we'll add in later. Shadow here. So I'll get that lighting in the background, and I'll get that lighting in the background too. See how we go. Any questions?
Have you got any thoughts on this new Unreal game engine coming to the web? Have you heard much about that?
We were talking about that
Yeah.
before we started. Not specifically, although there's going to be a bit of a. It seems like there's going to be a number of different elements in there. Oh, sorry, I'll back up. Let's take it from the perspective that some of the stuff that we do in CSRO, we generally would like a silver bullet, like a system on one size that does everything that we're looking for at the moment. So we've got PC, Linux, OS X, mobile platforms, web delivery, that sort of stuff. Still don't think there's anything there. Unreal, maybe, if they get that sort of piece. Unity's probably been the closest thing we've generally seen towards that line. But there's limitations. And with Unreal Engine, you don't get access to the source code unless you're willing to spend amounts of money.
Wasn't there a Chrome project to get some C++ running native? Was that Chrome a while ago?
That's native Maple.
Maple?
No, the native.
Looks like we might be time's up, if you're ready. How long have we got?
That's all
Yeah, good point, Tom.
So,
The question, who likes Unreal Engine enough to want to see it on the
can I put my hands through the floor? So,
Yeah.
But if nothing else, I mean, it's a sign of, WebGL is going to be a bigger thing than what it is now, at least, isn't it?
Unreal's tool set is really quite good. The source code is wonderful. But, admittedly, if you don't have the source code, then maybe that's not such a big issue.
I'm willing to bet they didn't rewrite the engine in JavaScript. I'm betting they'll be using Inscription that I mentioned earlier, that just takes the C++ code and
Or we just cross
cross
it with
yeah.
Unity. And,
Yeah, I think they're
they
using
put
the
it
same
in
thing.
plugin. So,
And I think they've both done it with Flash as well, haven't they?
is that right?
I know that if you look on, Adobe have released a bunch of JavaScript stuff that's really cool on their website that's open source now, including, I think they've now made it free. You used to have to pay for it, a thing that basically compiles your C code into Flash.
Successfully. Well, that's the end of my talk, because I also feel like my map. And actually, I would mention that stability-wise, generally speaking, it's been very stable, but there are the occasional gotchas. So,
You mentioned casings, I think that was, dealing with the this pointer in Java.
what's that?
Dealing with the this pointer in Java.
In JavaScript.
JavaScript.
Yeah.
Could you elaborate on that?
Yeah, I'll give you a bit more on that if you're interested. Basically, everything in Java is an object. JavaScript is an object. So if you're calling through code, which I can show you an example of it, but let's just say when you're dealing with JavaScript in HTML, you can put some scripts in your header, your head section of HTML, and they'll get executed first before any of your document loads. Or you can put scripts sort of direct in your document code as well. Generally speaking, the best idea is to any supporting utilities and things that don't necessarily manipulate your data, you do those in your header, and so you're loading through JS and things like that, for instance. And then you use a callback, which by default is the on-web load. You can put in the first line of your body, so that once your document has been loaded and the data is ready, then it will call your code to start executing. Okay. Now, at any stages in those, if you declare a var, which is just their generic variable, because there's no types, everything's a var, more or less, you can treat it more or less as an object. Now, you can assign to that object, you can assign members just by saying, say x dot color, just something totally intuitive example, but x dot color equals something, or you can say x dot set color equals function, and then you can provide a function for it. Now, ordinarily in object-oriented programming, if you create a method for an object, you would presume that you could access the this pointer of that object, and it would make meaning. So in that x dot set color, we could access the this dot color. You can't, because in that overall script as it's executing in what's called the window. Okay, it's the overall window object, if you like. Now, if it calls window.setColor, inside setColor, if you call the this pointer, it refers to that window object, because that's the current executing object, if you like. Now, by contrast, if you create a callback inside your object, that maybe it sets itself up on a timer or something like that, then it can, once the callback gets called back, it'll get called on that object, if you like, and the context of this point, if you like, swaps to that object itself. And I'll probably be able to show you some code for things called closures, which might make it a little bit more sensible, but I can't at the moment. In fact, I'm going to just try and pull that down. What it essentially revolves around is in that code that's executing at the top level, when you create an object and you create a method that you want to effectively work on that object at this point, you assign the object to a local var, just you declare a var and you call it something, that's called a closure, and then in the scope of that overall method, you use that variable name again somewhere inside that object, inside a method call, it will know it's calling it on the object you just created. Sorry, there's a lot of hand waving going on here. But to take an example, that if you could say, sometimes I use the word that rather than this. So you go, blah, 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 and if you're creating a sphere, you go var that equals create sphere, something like that. It returns a sphere object and assigns it to that. Now, next method call might be I might have a callback function, and if I want it to refer to the actual sphere object, I'll use that inside of it, because it's still in the same, if you step up the scope, it can still see that object, if you like. And it's kind of hard to show without showing the pictures. But yeah, if you look for closures, lambda functions,
The module pattern, I think that's sort of related to what you're talking about.
could be.
There's a book called JavaScript: The Good Parts, which is highly recommended reading if you actually do want to really get into JavaScript.
Yeah, it's a whole heap of online resources for it. Those two things, the type and if that's what the pattern's called, the module pattern, probably the ones that-
Where you define an anonymous function and just call it straight away, so that you've got some scope that you can
Yep.
not leak into the global scope, basically.
So they're probably the most talked about that I've seen as I've searched for expertise in JavaScript. I'm no major expert in JavaScript. It's interesting. It's actually in full screen
Yeah, having made the tricky transition from a very traditional C++ program to learning JavaScript it's really, it's a bit of a, does remind you a bit when you start, but once you learn it, it's actually really powerful in terms of like what it's meant to be, a high-level language where you can get stuff done quickly.
Yeah.
And with the stuff like closures is effectively like wrap a function with certain things, and there's actually a lot of functions added in there where you can, for instance, with the stuff about this thing, you can actually bind this pointer to a function and effectively box it up, so that you can basically create a version of that function that you can treat like a variable that always gets called with a particular this value. And you can also bind your first couple of function arguments. So there's all these different ways to kind of box things up in different ways and pass data around. That
So I think that's the major spin out, isn't it? Is that you can actually change this pointer to be whatever you want for whatever function.
yeah. which sounds horrible to somebody who comes from like a C background.
Yeah.
But once you're used to it, you actually realize it enables duck typing. If people know what duck typing is, where it's like if it looks like a duck and quacks like a duck, you can treat it like a duck.
Trying to see if we can give a different example, but it might take a bit to drill down a bit.
Also sort of templates with method concepts.
Yeah, it's a bit like a lot of the C++ stuff. It's enough rope. It's one of it's like if you're a bad programmer, you can get yourself in all sorts of trouble. But if you know what you're doing with it and you use it well, it's incredibly powerful.
It doesn't matter. It's within the browser. You want to kill the browser.
There's a lot of similarities.
Well, that's the thing. The more stuff they add to the browsers, though, like as we just saw a second ago, you can kill a PC now with it in crack code.
I think that brings to the question I wanted to ask is the hardware requirement for the WebGL to display.
What's
Like 3D acceleration cards or something, the hardware requirement?
I think you probably find it's pretty minimal. OpenGL ES2 doesn't have a huge.
I think that's OpenGL 3, doesn't it? GS2.
Oh, it's
On
in
hardware
between.
level.
Yeah, it's in between 2 and 3, and it's been out a long time. Yeah. So,
I had an interesting experience with it actually on my laptop, because my laptop's got a, I think it's an NVIDIA graphics card, but it's it's not a great one. And for some reason, I don't know why, it was blacklisted by WebGL or Chrome or something like that.
So you're forced to disable it.
Well, after I did a bit of research, I found that there was a command line parameter that allows you, for Chrome, that allows you to disable the blacklist, which made WebGL work on my laptop. I've never had a problem with it running on my laptop, so I don't know why.
You know, the blacklist, I was going to say, what the blacklist is for is that there's a known, that usually means there's a known vulnerability in your graphic card driver, where if somebody writes some malicious WebGL, they can hack your PC.
Yeah.
That's why they blacklist and stuff usually.
okay. Yeah, just thinking I'll probably go to the great example of what we were talking about before. What have we got? This city example, no, that doesn't do it. Sorry. Probably not a great example. This creates a gauge on the screen, but not even a good example in the stuff that we're looking at. Yeah, geo, does that.
What's the time here? Should people wait in the beginning?
I don't think so. So, wait, should we get
Just
to
look at the pictures.
the best parts or the best bits, which was
Just write something.
the good parts, I think.
There's some bit of
Quite properly.
That's better.
There you go. So if you can think about that one.
Ah!
No, I can do it.
All right. Well, that's pretty much it, guys. Thanks for listening.
Thank you.